ኦኬ ሰላም ሰላም፣ እንዴት ናችሁ? ደህና ናችሁ ወይ? ዛሬ የምናየው ዴቨሎፐር አሶሺየት ኤግዛም ፕሪፕ ነው። እስቲ አብረን ስኪል ቢልደር ላይ ሎጊን አድርገን በሲሙለርን አብረን እንከታተል ማለት ነው። እኔ እየተዘጋጀው ስለሆነ የምዘጋጀውን ደግሞ ለእናንተ ሼር አደርጋለሁ ማለት ነው። እንግዲህ ኢዚ ፍሎ ነው የሚሆነው። አብረን ነው ጥያቄዎችንም የምንሰራው። just to make sure እየተላለፈ መሆኑን make sure go to account view your channel actually. Okay, perfect. Okay, I think I have to create another source. Okay, perfect. We came to the right page now. Very good. Okay, let's go to explore by product domain. I think maybe by certification to developer. And we're gonna do ይሄኛው ዶሜን ዋን ላይ ነበርን። ስለዚህ ዶሜን ዋን ላይ እንቀጥላለን ማለት ነው። ባለፈው ሰርቨርለስ ኢንፍራስትራክቸር ሰውየው ፍጠሩልኝ ብሎ መጥቶ ላምዳን ሬከመንድ አድርገን ኤፒአይ ጌትዌይን ሬከመንድ አድርገን ከዛ ወደ ዳይናሞ ዲቢ ላይ ነበርን። እስቲ እንግዲህ እንቀጥላለን ማለት ነው። አይ ቲንክ ሁሉንም አግኝተነዋል። ለስቶሬጁ ዳይናሞ ዲቢ ሰርቨርለስ SQL, I think NoSQL or SQL. Let me get my support here. Is DynamoDB SQL or is DynamoDB SQL or NoSQL? እሱ መጠየቅ ስለምንችል oh yeah, NoSQL. NoSQL ማለት if a SQL database like MySQL or PostgreSQL is like a well-organized library, every book data has to fit neatly into predefined shelves. tables with fixed columns. Then DynamoDB is like a flexible storage room. You can store any kind of item data in labeled boxes, items with key value pairs, even if each box has different content. Key difference. SQL, that means structured query language. That was easy, guys. Structured query language na SQL ማለት ነው። SQL ሲባል ነው SQL ሲባል ሌላ ነገር ይመስለናል። SQL ማለት structured query language database, fixed structure, table, row, column. NoSQL, not only SQL. Databases like DynamoDB, flexible structure, key value, or document format. DynamoDB strengths: fast and scalable, automatically handles high traffic, secure, integrates with IAM, great for real-time apps like patient monitoring, dashboard, or scheduling system in home health. Okay, so NoSQL አግኝተናል ማለት ነው። ኦኬ፣ ስለዚህ ይሄኛውን ነው የምንሄደው ራሳችንን ለማለት አክሰፕት። ኦኬ፣ ባለፈው ሁሉንም ሬከመንድ አድርገን ነበር ወደ ቢልድ አድርጉት ወደሚለው ቢልድ ወደሚለው ፌዝ ላይ ነበረ። ቴክስት ተላለፈው መሆኑን በስርዓት በዙፋኑ ላይ የተቀመጠው የሚመልስ ነው የኔ አምላክ ጸሎት የሚሰማ። ኦኬ፣ አሁን ቢውልድ እናደርጋለን። አንዴ ሚቲንግ ሰመሪውን እኔ assignment was building a serverless create, read, update, delete የሚያደርግ application, CRUD application. AWS meeting simulation, 100% client satisfaction. We had a great communication skills. That means we listened, we understood what he's saying, and we made sure that we understood by actually saying it. And then our problem solving skill. We gave him what he needs, or what we solved his problem by giving him a solution that exactly fits his problem. Customer focus. We were going by his need, not by what AWS should benefit, but what his company needs. Customer focus, plus making him feel rest assured and about his team, answering all his questions, and decision making skill. We had to decide on the tools, on the services based on his need. Technical knowledge. We explained how it works, how those tools, how the Lambda works, only when he needs, that it is serverless and no need to manage servers, and API gateway. It's also we can just get a summary of what API gateway is. What is API? It's like a waiter that will serve, that will make sure that only good people come in, only legit people come in and get served by Lambda. What's API gateway? API gateway is a front desk or receptionist of your healthcare system, the one who decides who gets in, where they go, and what information they can access. What it does, It handles incoming requests just like patients arrive at your clinic with different needs. Apps and users send requests. API gateway receives those requests first, like get patient info or update medication list, and then it routes requests to the right department. After checking what the visitor needs, the API gateway ensures the visitor is authorized using tools like AWS IAM, Cognito, or API keys. Checks ID and permissions. Actually, um, routes requests to the right department is after checking what the visitor needs, it sends them to the correct backend service. For example, one service for patient records, another for care plans, etc. In cloud terms, it routes to Lambda, ECS, or DynamoDB. 3 checks IDs and permissions, just like a nurse checks insurance or ID. API gateway ensures the visitor is authorized using tools like AWS IAM, Cognito, or API keys. Okay, only verified users can see or change data. 4 monitors and protects the system. It keeps logs, monitors for unusual activity, and blocks harmful requests, kind of like your clinic's security cameras and infection control. Works with AWS WAF to block hackers or bots. Why it's important? Keeps your data safe, HIPAA compliance ready, reduces complexity. AWS handles security and scaling, makes it easy for your team to build and manage APIs without managing servers, allows secure, organized communication between your mobile apps, dashboard, or partner system. In short, Amazon API Gateway, the smart, secure receptionist for all your healthcare data and apps, managing traffic, checklist, checking identities, and protecting your system. Okay. So, ባጭሩ API ጌትዌይን ብንጠቀልለው it's a system that will securely route requests to the appropriate destination, like Lambda, ECS, DynamoDB, EC2. And it uses IAM and what else? Security protocols. What other security? AWS IAM, Cognito, and API keys to what? To check. Just like a nurse checks insurance or ID, API gateway ensures the visitor is authorized using tools like AWS IAM, Cognito, and API keys. Okay, let's go. Now let me download. Oh, there, I can download this, guys. Building serverless CRUD application. That is perfect. Let me see. Oh, nice. ከዳውንሎድ አድርጎልናል ማለት ነው። ቢውልድ ያደረግነው ወይም ቢያንስ በዲዛይን ሌቨል ቢውልድ ያደረግነው ማለት ነው። Okay, so we got Amazon API Gateway, which is like a waiter, or it makes sure requests are sent to the appropriate backend, and it makes sure by using AWS IAM, Cognito, and API keys that those requests are authorized, like a nurse checks ID, and it checks for them having those fingerprints of authorization from IAM, Cognito, and API keys. This is an important place, otherwise any legal requests, DDoS attacks, and penetration attacks, things like that might go in and access information and then leak back to the wrong user. So this checks if this user is actually legit. Okay. Oh, is it a slideshow? Just one page, right? Oh, what? I didn't know. Okay, good. Oh, okay, okay. It was showing me the previous AI practitioner escape room. Okay, so we're gonna be done with this and done with this. Let's go, continue. We're gonna do it, I think it's that, I think it might be DIY phase now. Mm, okay, build, yeah, now we're gonna build. So Major Jack said last time, thanks for recommending Amazon API Gateway. Sounds perfect. Um, for securing our API and managing all those incoming requests, this will definitely help us control access properly. Okay, so we're gonna build it now, okay? Let's build. Acquire, so number one is learn. Acquire the theory and fundamentals of the cloud architecture. Architecture for visual clarity, clear breakdown of concepts for ready comprehension, detailed explanation and videos on each service. Practice. Gain hands-on experience through guided tutorials in AWS labs, step-by-step mm, step-by-step instructions for implementation, architecture diagrams for visual reference, and screenshots of labs, lab steps for guidance, and 3D DIY. Apply acquired knowledge to solve challenges independently, task-based challenges to test skills, support files and architecture diagrams provided, validation of solution for assessment. Okay, so let's go. Okay, so meet your AWS assistant. Our AI assistant is here to provide instant support throughout the AWS Simulearn experience. Whether you're learning, practicing, or tackling challenges independently, our AI assistant offers detailed explanations, helpful resources, and guidance on AWS resources and concepts, services and concepts. Okay, yeah, that's Dr. Newton. He wasn't super helpful last time, so let's see this time. Okay, so now we are on the learning step, I think, still, which is fine for me. Solution request using Amazon API Gateway, AWS Lambda, and Amazon DynamoDB. This solution builds a serverless CRUD, which is create, read, update, and delete API that is reliable, highly available, and scalable. This solution creates serverless CRUD, create, read, update, and delete API that is reliable, highly available, and scalable. And right at this moment, I just want to ask again API abbreviation. Why did they call it API? Application Programming Interface, is it? API stands for Application Programming Interface. Let's break it down simply with home health analogy. Think of an API as a messenger or bridge that allows two systems or apps to talk to each other safely and clearly without confusion or chaos. Just like a nurse passes information between the doctor and the patient, an API passes information between apps. For example, between your home health app and database like DynamoDB. In tech terms, an API defines how software components interact, what data they can ask for how to send it, and how they receive responses. For example, your home health uh, app says, get me patient ID 100 101's vitals. The API delivers the requests to the database. The database returns the vitals data through the same application programming interface. So API, application programming interface, is the safe messenger between apps and systems. Okay, step 1. This solution creates a serverless CRUD API that is reliable, highly available, and scalable. Okay. Amazon API Gateway acts as a front door for applications to access data, business logic, or functionality from backend services. Amazon API Gateway Overview.
Amazon API Gateway Overview. Amazon API Gateway is a fully managed service that developers can use to publish, maintain, monitor, secure, and operate APIs at any scale. API Gateway is a pay-as-you-go service that removes the heavy lifting involved in securely and reliably running APIs at scale. APIs act as the front door for applications to access data, business logic, or functionality from your back-end services. Using API Gateway, you can create RESTful APIs and WebSocket APIs that enable real-time, two-way communication applications. Key features: support for RESTful APIs and WebSocket APIs. With API Gateway, you can create RESTful APIs by using either HTTP APIs or Representational State Transfer, or REST APIs. HTTP APIs are the best way to build APIs that do not require API management features. They are optimized for serverless workloads and HTTP backends. REST APIs are used for workloads that require API proxy functionality and API management features. WebSocket APIs are used to build real-time, two-way communication applications, such as chat apps and streaming dashboards. Resiliency. You can use API Gateway to set throttling rules based on the number of requests per second for each HTTP method in your APIs. This helps you manage traffic to your back-end systems. API Gateway handles any level of traffic received by an API, so you are free to focus on your business logic and services rather than maintaining infrastructure. AWS Authorization. To authorize and verify API requests to AWS services, API Gateway can help you when using Signature version 4 for REST APIs and WebSocket APIs. Using Signature version 4 authentication, you can use AWS Identity and Access Management (IAM) and access policies to authorize access to your APIs and all your other AWS resources. Benefits: performance at any scale. Provide end users with the lowest possible latency for API requests and responses by taking advantage of the AWS global network of edge locations using Amazon CloudFront. Streamlined monitoring. Monitor performance metrics and information on API calls, data latency, and error rates from the API Gateway dashboard, which allows you to visually monitor calls to your services using Amazon CloudWatch. Efficient API development. Run multiple versions of the same API simultaneously, allowing you to quickly iterate, test, and release new versions. Applications can continue to call previous API versions even after the latest versions are published. API Gateway also helps you manage multiple release stages for each API version, such as alpha, beta, and production.
Okay, I'm just gonna take a screenshot of those things. Okay, and I'm gonna feed into ChatGPT so it can explain to me. Okay. Explain. I'm just feeding the whole screen, everything that was said, and then I'm just gonna ask her. Super important we stay in one concept and master it before we go ahead, because it might be embedded in every lesson, and we might have those dark spots if we don't like በደንብ ካላስተማርነው አንዱን ነገር አንዱን አይዲያ በየጊዜው ስለሱ ሲነሳ dark spot ይሆንብናል ሌላውንም
Perfect. You're looking at a visual summary of Amazon API Gateway from AWS Skill Builder. Let's unpack what you see in that image in simple, practical, and healthcare-friendly terms. And imagine this. Your home health service has a mobile app where caregivers record patient visits, vitals, and care notes. That app needs to safely talk to your database, like DynamoDB, in the cloud. But instead of letting every phone or computer connect directly to your database, which is risky, you place a front door. That's Amazon API Gateway. Overview, top section. Amazon API Gateway acts as the front door for all your application data requests. It receives requests like get patient vitals or update care notes, checks if they're valid and secure, and sends them safely to the backend services, like Lambda or DynamoDB. It then returns the right response to the app user. It also works with IAM or Cognito for user identity verification, checking if the user is allowed in, AWS WAF for security, filtering out hackers or bots, CloudWatch to monitor activity, errors, and performance. So API Gateway equals reception plus security guard plus traffic controller for your app data. Shack key features, bottom left. 1. Supports RESTful and WebSocket APIs. REST equals one-time requests, like get patient info. WebSocket equals real-time communication, like live updates or monitoring. 2. Resiliency. It can handle high traffic safely, throttling requests so the system doesn't crash. 3. AWS authorization. It uses IAM and tokens, like secure badges, to verify who's allowed to send or receive data. Here are benefits. Bottom right. 1. Performance at scale. Runs globally on AWS infrastructure, so even if many caregivers use the app at once, it stays fast and reliable. 2. Streamlined monitoring. You can track performance, latency, and errors, like having a dashboard for all your app's health stats. 3. Efficient API development. You can easily create, test, and release new versions, like updating your app features, without rebuilding everything. HAT, in short, concept, analogy, API gateway role, security guard, checks IDs and badges, controls who gets in, Cognito IAM, reception desk, routes visitors, sends requests to correct backend, Lambda DynamoDB, traffic police, manages flow, handles large numbers of requests, CCTV system, monitors activity, logs and monitors via CloudWatch. Would you like me to turn this into a one-slide training visual titled Amazon API Gateway, the front door of your home health cloud app, that you can include in your PowerPoint for staff or clients? Perfect. You're looking at a visual summary of Amazon API Gateway from AWS Skill Builder. Let's unpack what you see in that image in simple, practical, and healthcare-friendly terms. And imagine this. Your home health service has a mobile app where caregivers record patient visits, vitals, and care notes. That app needs to safely talk to your database, like DynamoDB, in the cloud. But instead of letting every phone or computer connect directly to your database, which is risky, you place a front door. That's Amazon API Gateway. Overview, top section. Amazon API Gateway acts as the front door for all your application data requests. It receives requests like get patient vitals or update care notes, checks if they're valid and secure, and sends them safely to the backend services, like Lambda or DynamoDB. It then returns the right response to the app user. It also works with IAM or Cognito for user identity verification,
Amazon
checking if the
API
user is allowed in,
Gateway
AWS WAF for security, filtering out hackers or bots, CloudWatch to monitor activity, errors, and performance. So API Gateway equals reception plus security guard plus traffic controller for your app data. Shack key features, bottom left. 1. Supports RESTful and WebSocket APIs. REST equals one-time requests, like get patient info. WebSocket equals real-time communication, like live updates or monitoring. 2. Resiliency. It can handle high traffic safely, throttling requests so the system doesn't crash. 3. AWS authorization. It uses IAM and tokens, like secure badges, to verify who's allowed to send or receive data. Here are benefits.
Amazon API.
Bottom right. 1. Performance at scale. Runs globally on AWS infrastructure, so even if many caregivers use the app at once, it stays fast and reliable. 2. Streamlined monitoring. You can track performance, latency, and errors, like having a dashboard for all your app's health stats. 3. Efficient API development. You can easily create, test, and release new versions, like updating your app features, without rebuilding everything. In short, concept, analogy, API gateway role, security guard, checks IDs and badges, controls who gets in, cognito IAM, reception desk, routes visitors, sends requests to correct backend, Lambda DynamoDB, traffic police, manages flow, handles large numbers of requests, CCTV system, monitors activity, logs and monitors via CloudWatch. Would you like me to turn this into a one-slide training visual titled Amazon API Gateway, the front door of your home health cloud app, that you can include in your PowerPoint for staff or clients?
Okay, so እነዚህን ቤዚክ ፊቸሮች እስቲ one more time summarize እናድርጋቸው። Amazon API Gateway Overview Support RESTful and WebSocket APIs ምንድን ነው RESTful የሚለውን እዚህ ጋር ሄደን እንመልከተው። RESTful ማለት REST one-time request like get patient info. WebSocket real-time communication like live update or monitoring. Okay, that's what it means. So RESTful ማለት የአንድ ጊዜ ብቻ ዳታው ጀስት ቁጭ ብሏል ግን አንድ ጊዜ ነው። ሪኩዌስት ወይም ሁለቴ ወይም የሆነ እያረፈ ግን ሪኩዌስት ሲመጣ የሚመልስ ማለት ነው። WebSocket ደግሞ የሚለው ላይክ ላይቭ አፕዴቶችንም ጭምር ማለት ነው። እሺ ነው right? Okay, there you go. Okay, API gateway create RESTful APIs and then using HTTP or REST APIs, and then HTTP APIs do not require management features, and then from HTTP or REST APIs we go REST API, and then REST API requires API proxy management features. Okay, next one used for people talking to each other. Oh, I see. WebSocket is live, like directly. And then
Amazon API.
no, I don't want you to play again. Let's go.
Amazon.
No, again. Okay, let's just stay here. Or I can just use. Oh yeah, let me just. Okay, I'm just gonna take a screenshot of the whole thing. Okay? Let me see. Oh, we went back. Okay. Okay, I think we can just zoom this in and out easily. No, I don't need to write on it. I'm like, if it can where did I put it? API, let me find it here. Should bring in the front, but it's not, so it's okay, I found it. Okay. So API gateway, RESTful API serverless HTTP, then chat people, streaming. WebSocket is for chat with people and streaming. So they support both RESTful API and WebSocket. Resiliency, okay, this is API gateway. It has door, pink background in white door, and then API gateway based on number of requests, throttling rules for it. What is throttling? Because we can ask. We can definitely ask each and every word so we know what we're learning about. Okay. Throttling means controlling the flow of traffic to your system, like putting a speed limit on how many requests or data message your API can handle per second or per minute. It's putting data limit. Is it? What speed limit? Okay, so throttling rules or speed limit. Gonna set speed limit. Okay, number of requests based on, okay, API gateway set throttling rules or speed limit based on number of requests for each HTTP method in APIs, and then manage traffic and backend systems, and then API gateway focus on business logic rather than infrastructure. Okay, what else? AWS authorization. Okay, authorize and verify API requests to use AWS services. API gateway signature version 4 for RESTful API, WebSocket, access policy, AWS identity and access management, performance at scale in the users with lowest latency, API requests, so that means like low latency corner, high speed no ones, no? And then API requests and responses take advantage. AWS global network of edge location provided through Amazon CloudFront. Okay, streamlined monitoring, monitor performance metrics, API calls, data latency, error rates, API, Amazon API gateway dashboard, efficient development, run V1, V2, V3, multiple API version, iterate, test, release, new version, application API gateway. Okay, let's go back to where we were, guys. Okay, I think I should do the whole screen. Okay, let's go. I'm gonna put this down, put it down. So number 3, API Gateway invokes AWS Lambda functions that process the data, uses DynamoDB as a data store. Difference between SQL and NoSQL.
Difference between SQL and NoSQL databases. There are a few key differences between SQL and NoSQL databases. Optimal workloads. Relational databases are designed for transactional and strongly consistent online transaction processing (OLTP) applications. They are also good for online analytical processing (OLAP). On the other hand, NoSQL, key value, document, graph, and in-memory databases are designed for OLTP for a number of data access patterns that include low-latency applications. NoSQL search databases are designed for analytics over semi-structured data. Data model. The relational model normalizes data into tables that are composed of rows and columns. A schema strictly defines the tables, rows, columns, indexes, relationships between tables and other database elements. The database enforces the referential integrity and relationships between tables. NoSQL databases provide a variety of data models that includes key value, document, graph, in-memory, and search. Or you can design custom data models based on your specific query patterns. ACID properties. Relational databases provide atomicity, consistency, isolation, and durability. Atomicity requires a transaction to execute completely or not at all. Consistency requires that when a transaction has been committed, the data must conform to the database schema. Isolation requires that concurrent transactions execute separately from each other. Durability requires the ability to recover from an unexpected system failure or power outage to the last known state. DynamoDB transactions provide developers ACID across one or more tables within a single AWS account and region. NoSQL databases are an excellent choice for high-throughput, low-latency use cases that need to scale horizontally beyond the limitations of a single instance. Performance. Performance is generally dependent on the disk subsystem, and optimization of queries, indexes, and table structure is often required to achieve peak performance. However, performance is also a function of the underlying hardware cluster size, network latency, and the calling application. Scale. Relational databases typically scale up by increasing the compute capabilities of the hardware or scale out by adding replicas for read-only workloads. NoSQL databases typically are partitioned because key-value access patterns are able to scale out by using distributed architecture to increase throughput. APIs. Requests to store and retrieve data are communicated using queries that conform to a structured query language. SQL object-based APIs allow app developers to easily store and retrieve in-memory data structures. Partition keys let apps look up key-value pairs, column sets, or semi-structured documents that contain serialized application objects and attributes.
Okay. I'm gonna take a screenshot of this. Okay, let me see. Is it the same thing? Performance scale. Okay, let ChatGPT explain this. We're gonna ask her to read for us. Okay, read it out loud for us, Miss.
Perfect. This image compares SQL versus NoSQL databases using visuals similar to AWS training materials. Let's explain this in simple, real-life terms. Using your home health example, imagine a home health agency. You have lots of patient records, caregiver notes, and visit schedules. How you store and retrieve that information depends on the type of database you choose. There are two main types: SQL, structured query language, organized and rule-based. NoSQL, not only SQL, flexible, and fast SQL, the filing cabinet with perfectly labeled folders. Best for structured, predictable data, like patient demographics, billing, or visit records, where accuracy and relationships matter. How it works: everything is stored in tables with rows and columns, like Excel. Every record must follow the same format, like each folder has the same label style. Relationships between tables, like patient visit caregiver, are strictly defined. Core qualities, acid properties. Atomicity, all or nothing, like either the whole note saves or it doesn't. Consistency, rules are followed, no missing data. Isolation, one update doesn't mess up another. Durability, once saved, it stays safe. Scaling, to handle more data, SQL usually scales up. Bigger, stronger server, like adding more drawers to your filing cabinet. Example: Amazon RDS, like MySQL, PostgreSQL, perfect for patient records, billing, and compliance-heavy tasks. NoSQL, the smart whiteboard or notes app. Best for unstructured or fast-changing data like caregiver notes, IoT health readings, or app logs, when you need speed and flexibility. How it works: data stored in key-value pairs, documents, or graphs, less rigid. No fixed schema. Every record can look a little different. Handles high-speed, large-scale data easily. Hash scaling. Scales out horizontally. Add more servers instead of making one huge one, like hiring more assistants instead of buying a bigger desk. Performance. Very fast, low latency, high throughput, can handle lots of data traffic. Example: Amazon DynamoDB, perfect for apps tracking patient vitals, caregiver locations, or real-time updates. Quick summary: table, feature, SQL, NoSQL. Structure, fixed. Tables, schema, flexible, documents, key value. Best for relational data, unstructured, fast-changing data. Scaling, vertical, bigger server. Horizontal, more servers. Speed, slower but consistent. Faster, adaptable. Examples: Amazon RDS, Aurora, Amazon DynamoDB, DocumentDB. Analogy: filing cabinet with labeled folders, digital whiteboard with sticky notes. In home health context, use SQL for billing, scheduling, compliance, and reporting. Use NoSQL, like DynamoDB, for real-time caregiver tracking, visit logs, or IoT health sensor data. Would you like me to turn this into a one-slide AWS home health training visual titled SQL versus NoSQL, choosing the right database for patient care? It would fit beautifully into your home health plus cloud teaching materials.
Thank you, Miss. You're super helpful. So let's go to the next one. DynamoDB is a key value and document database that delivers single-digit millisecond performance at any scale. Amazon DynamoDB overview. Let's do this.
Amazon DynamoDB Overview. Amazon DynamoDB is a key value and document database. It delivers single-digit millisecond performance at any scale. It's a fully managed, multi-region, multi-active, durable database with built-in security, backup and restore, and in-memory caching for internet-scale applications. DynamoDB can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. Here are the key benefits. Performance at scale. DynamoDB is a key value and document database that can support tables of virtually any size with horizontal scaling. Since DynamoDB is both a key value and document data models, it enables flexible schema, which allows you to adapt to your business requirement change easily. For use cases that require even faster access with microsecond latency, DynamoDB Accelerator, or DAX provides a fully managed in-memory cache. Using DAX, you can improve the read performance of your DynamoDB tables by up to 10 times. The time required for reads reduces from milliseconds to microseconds, even at millions of requests per second. DynamoDB global tables replicate your data across multiple AWS regions to give you fast, local access to data for your globally distributed applications. DynamoDB streams capture a time-ordered sequence of item-level modifications in any DynamoDB table and store this information in a log for up to 24 hours. DynamoDB provides both provisioned and on-demand capacity modes. Tables using provisioned capacity mode require you to set read and write capacity. For workloads that are less predictable, on-demand capacity mode takes care of managing capacity for you, and you only pay for what you consume. With the two capacity modes, you can optimize costs by specifying capacity per workload, or paying for only the resources you consume. For tables using on-demand capacity mode, DynamoDB instantly accommodates your workloads as they ramp up or down to any previously reached traffic level. For tables using provisioned capacity, DynamoDB delivers automatic scaling of throughput and storage. If your application traffic grows, DynamoDB increases throughput to accommodate the load. If your application traffic shrinks, DynamoDB scales down, so that you pay less for unused capacity. DynamoDB integrates with AWS Lambda to provide triggers. With triggers, you can build applications that react to data modifications in DynamoDB tables. The Lambda function can perform any actions you specify, such as sending a notification or initiating a workflow. Encryption at rest. DynamoDB encrypts all data by default. Encryption at rest enhances the security of your data by using encryption keys stored in AWS Key Management Service. ACID transactions. It provides native server-side support for transactions, simplifying the developer experience of making coordinated, all-or-nothing changes to multiple items both within and across tables. Point-in-time recovery, or PITR, helps protect your DynamoDB tables from accidental write or delete operations. PITR provides continuous backups of your DynamoDB table data. You can recover to any point in time up to the second, during the preceding 35 days with no downtime. On-demand backup and restore. You can create full backups of hundreds of terabytes of data instantly with no performance impact to your tables. The archived data can help you meet your corporate and governmental regulatory requirements. DynamoDB is also backed by a service-level agreement for guaranteed availability.
Nice. As a page to screenshot and give it to Miss ChatGPT. Explain with analogy. She's gonna bring it down to our language. Let's see.
Perfect. This visual beautifully explains Amazon DynamoDB, and we can make it come alive using an analogy from your home health business. Let's imagine DynamoDB as your smart home health command center, the system that manages all your caregivers, patient data, schedules, and reports across many cities without ever slowing down. Overview. Your command center. Think of DynamoDB as your digital assistant that runs your entire home health business automatically, keeping every detail updated instantly and securely. Key value document data equals, like having patient files that can look different. Some have vitals, some have care notes, no strict format. Single-digit millisecond performance equals. It responds faster than a nurse answering a patient call. No delays. Fully managed. You never worry about hiring IT staff. AWS takes care of the servers. Multi-region, multi-active, like having branch offices in multiple cities. Each one always updated with the latest patient info in real time. Built-in security equals. Only authorized caregivers or managers can access sensitive data. Backup and restore. You can rewind time and restore yesterday's data if something goes wrong. Internet scale. It can handle millions of patient records, whether your agency serves 10 families or 10 million. Benefits. Performance at scale. Imagine your agency expanding nationwide. DynamoDB keeps up like a super efficient national coordinator. Flexible schema equals, each patient chart can grow differently as care needs change. Horizontal scale equals, instead of hiring one overworked manager, you hire more staff. DynamoDB adds more servers, nodes automatically. Global replication. If a caregiver in California updates a patient note, a manager in Texas sees it instantly. DynamoDB Accelerator, DAX, equals like keeping the most used patient files on your desk for instant access, microsecond speed. Real-time streams. Every time a caregiver updates notes, a real-time notification, trigger, can alert supervisors or update dashboards automatically. Benefits. Serverless. No servers, no maintenance. Just effortless scaling, like your agency adjusting caregiver shifts automatically. On-demand mode. If one day you have 10 patients and next day 1,000, DynamoDB automatically expands and contracts. You only pay for what you use. Auto-scaling, like hiring extra caregivers during busy flu season, then scaling down when demand drops. Triggers. When a new patient is added, DynamoDB can automatically notify caregivers via AWS Lambda, like your system sending task alerts to their phones. Header benefits. Enterprise-ready DynamoDB is built for reliability, like a hospital-grade data system. Point-in-time recovery, PITR, equals you can rewind your database to any second in the past 35 days, like replaying security footage to recover lost info. ACID transactions guarantees that all updates, like changing both a patient record and billing info, happen completely or not at all. No partial errors. Encryption at rest. All data is locked in AWS's key management vault, like keeping patient files in a double-locked cabinet. On-demand backup equals full secure backups of terabytes of data, instant and compliant with regulations like HIPAA. In summary, home health analogy. DynamoDB feature, home health analogy, fully managed. AWS runs your back office so you can focus on care. Multi-region replication. Branch offices always in sync. Flexible schema. Patient records adapt to different care needs. Serverless. No staff needed to manage servers. Auto-scaling. Automatically adjusts to patient volume. PR, recovery. Time travel to fix accidental data errors. Encryption, HIPAA-grade data protection. DAX, instant access to frequently used info. Would you like me to turn this into a teaching slide or LinkedIn visual post, like how Amazon DynamoDB powers home health data systems? It would make this concept super clear and shareable.
Okay, so now we're gonna practice. Continue. Step 1, review the practice lab objective in the concept section, which is this section. In this practice lab, you will create an Amazon DynamoDB table. Use AWS Lambda function to read and write data from the DynamoDB table. Create and test an Amazon API, Gateway API. Deploy and test the API Gateway, API endpoint. Review the practice lab objective in the concept section. Click Start Lab or open AWS console to begin. Follow the lab instructions carefully and use the arrows to navigate between steps. AWS services not used in this lab are disabled in the lab environment. In addition, capabilities of the services used in this lab are limited to what the lab requires. Okay, so we already reviewed the objective. We're building DynamoDB table, Lambda, and API gateway and endpoint. 4 things, right? Creating an Amazon DynamoDB table, and then AWS Lambda function to read and write from the DynamoDB table, and we're gonna create and test Amazon API gateway API, and then we're gonna do API gateway API endpoint. Okay, so we're gonna go. We got 51 steps First we have to click this. And then we're gonna do 2 pages, guys. One here and one here. Okay, what are we doing? We are looking for okay, so step 1 in the top navigation bar, type for dynamo. We're gonna get that one. What are we doing next? Left navigation pane, click tables. I might need 2 monitors for this, but alright guys, we're gonna continue next time from where we stopped. Thank you.